Hello. This video is going to show how we can achieve functional safety using Intel Quartus Nios II EDS. Now, I could have used a number of different evaluation boards for this demo, but in this particular case, I have connected to my PC at the moment an Intel Cyclone 10 LP, and that's the board that I'm going to run some tests on. Now, starting point is of course to have some programs. So in this particular case, I've created a BSP for my board, and then I've used that BSP to create a number of different applications. And we're going to start by looking at this very simple one here, where we have a main, and the main is simply calling a number of functions a certain number of times. Now, let's just check we can build this. So let's do a build, and there we can see it's successfully built. So the first thing I'd like to be able to do is I'd like to be able to look at my code and see, well, is it compliant to a coding standard such as MISRA 2012? I'd also like to be able to look at some of the functions inside my code and find out, well, how complex are they? What's the cyclomatic complexity of some of the functions? I'd then like to be able to execute the code, and as the code executes, I'd like to be able to find out, well, how much of this code have we actually exercised? And then finally, I'd like to be able to take a particular function and do some unit testing in order to get 100% statement, branch, and MCDC coverage on it. Now, we've done a build. Well, let's do a build, but this time within the build import system here. So I'm going to run basically the same build, but as the build runs, we're going to listen to what's happened. And from that, we can see we have an executable. We have a list of source files. We have a list of include paths. And also we have a list of preprocessor symbols. So basically, I have everything I need now in order to be able to open this in TV Vision and perform the analysis. Well, to save time, I've already done that. And so we can simply go and take a look at maybe a code review. And so here I've done a code review against MISRA 2012, and I have quite a few violations. Well, let's double click on a particular violation, and in this particular case, it's taken me to the place where that violation occurs, and we can see we have a define here that started with an underscore, and that's not allowed. Well, that will be very easy to fix. And similarly, a lot of other violations will be easy to fix. Now, what about the quality of this code? What about measuring metrics like the cyclomatic complexity? Well, we can view that on a system call graph. So the call graph is showing us all the functions. We can see how they're interconnected. We can see they're color-coded to show whether they're system calls or not. Well, let's put this into a mode where we can view metrics that give us an idea of maintainability. And the most interesting metric here is the cyclomatic complexity, and I can sort and find the most complex function. And so this function, integer to ASCII, has a cyclomatic complexity of 9. Well, let's view this graphically on a flow graph. And here we've got a graphic representation of that code. We have blocks of continuous statements followed by branches to other blocks. So we're able to highlight the various blocks. We can click on a block. We can see the corresponding block over here on the flow graph. Now, what I'd like to be able to do is execute this code. And as it executes, I want to be able to find out, well, what parts of the code have we actually exercised? And more importantly, which parts have we not exercised? So we're going to instrument the code. We're going to put probes inside each block, a probe at the start of the block and a probe at the end of the block. And then we're going to build that, execute it, and get the coverage. So let's close this down. Let's come back into TV Vision and let's perform the dynamic analysis. So this is going to perform the instrumentation. It's now doing the build. It's now executing on the target, and it's got the results back. And we're going to be able to now take a look at the results. Well, let's go back to our system call graph. And in this particular case, let's now put this into a coverage mode. And we can see we have 100% coverage for all the functions except the integer to ASCII. Well, let's view that graphically, again with a flow graph. And this time it's color-coded in green, showing us the paths we've taken. And in red, we can see the branches we've not taken, so we've not jumped from here to there, and we've also got some blocks of code that have not been executed. So if I want to get additional coverage for this, I could use the unit testing tool tbrun, where I'll be able to inject necessary the values in order to be able to execute these parts of the code that we've not covered. So let's go and invoke tbrun. All right, so inside tbrun, what I'm going to do is I'm going to load a sequence that I've created previously. So let me go and find a sequence here, and I'm going to load this in. And there we can see the function that I'm testing. We can see we have a number of inputs and expected outputs. And I'm going to execute this in order to get coverage. So let's go and execute this. So it's generated a harness. It's now built it. It's now downloading to the target. It's controlling the execution using, in this case, GDB. We're going to get the results from the target, and hopefully we're going to find that all our tests have passed. So that means with these inputs, we got the expected outputs that we're showing here. At the same time, we can now take a look at the coverage for our integer to ASCII function. And as we can see, we now have 100% statement coverage, 100% branch decision coverage, and also 100% MCDC. Okay, so hopefully that's given you an overview of how we can work with the Intel Quartus Nios II EDS. And if you'd like more information, then please don't hesitate to contact us at LDRA. Thank you.